All right, the product rule. If you're multiplying things together and you need to take the derivative of it, so the first derivative of two things, let's call them P of X and Q of X. If we're multiplying those two together, then to do this, we take P of X times the first derivative of Q of X plus Q of X times the first derivative of P of X. Yeah, it is not as simple as what it was. So a little more complicated with these. That's called the product rule. We will do the product rule over and over and over and over again this year. You will have it memorized. You should not have to look at your formula card for the product rule after a couple weeks. Okay? The product rule.
How many sections are we going over today?
3. But I'm going to explain them all right now and then just let you go.
So like Khan Academy test is Tuesday?
No.
Thursday.
Because we don't, okay, so we don't have school on Monday, and so tomorrow is a day. So we have class Tuesday, which is quiz and Khan Academy review.
Oh.
And then Thursday, I'll review for the AP test, and you'll still have some time to take the Khan Academy test because I won't be here Thursday afternoon. Afternoon, I'll be here in the morning half, but not the afternoon half. And then the next Tuesday, you'll take the Khan Academy or the AP classroom test.
So the Khan Academy one is on Thursday.
Khan Academy officially is on Thursday. I'll open it up Tuesday.
But it will be due the next
It'll be due that next Tuesday.
Okay, because I won't be here Thursday.
Okay.
I'll stay
Okay.
prep day.
Quotient rule.
Go Jacks.
The first derivative of P of X divided by Q of X equals the denominator times the first derivative of the numerator minus the numerator times the first derivative of the denominator all over the denominator, the normal denominator, squared. Okay, that's a quotient rule. Now this should already be on your note card. What's the first derivative of the sine of x? Cosine of x. What's the first derivative of the cosine of x?
Negative sine.
Negative sine of x. The first derivative of the tangent of x. Okay? That's going to be secant squared of x. In a little bit, I'll show you why it'll be secant squared of x. But this is just for writing purposes. Now you're getting it written down. So the first derivative of tangent x is secant squared of x. The first derivative of cotangent of x would be negative cosecant squared of x, which would make sense if you know your trig. The first derivative of secant of x is secant of x tangent of x. And the first derivative of the cosecant of x is negative cosecant of x cotangent of x. All right. So you got to know your trig functions. And these, when it comes to the AP test, these will have to be memorized. Okay, you'll have to have these memorized. But for now, up until that time, I let you use your note card because it's just easy to forget here and there. Okay, so now what I'm going to do is show you the product rule. Okay, so if you're told to take the first derivative of 2x minus 5 times 4x plus 7. Okay. So what we do is we take the first, 2x minus 5, times the first derivative of the second. What's the first derivative of 4x plus 7? 4. Plus the second, 4x plus 7, times the first derivative of the first, which is 2. So when we get 8x minus 20 plus 8x plus 14, which gives you 16x minus 6. Easy peasy lemon squeezy, right? Yep. Now let's prove why that's right. How would I prove that? Doing it the long way. Sounds good to me. So if we FOIL this, when we FOIL this, what's 2x times 4x? X squared. Outers, 14x. Inners, negative 20x. What's 14 plus negative 20? Negative 6x minus 35. Now if we take the first derivative of that, what would we get? I just proved that the product rule is what you get if you multiply those together and you take the derivative of each. Okay. Now you say, well, why don't we just multiply them together every time? Well, we will have more complicated problems than just a simple FOIL problem for the product rule. Okay? But let's say, what is the first derivative of 12x ln of x? The first derivative of 12x ln of x. Well, what's the first term there? 12x. What's the first derivative of the ln of x? 1 over x. Plus, what's your second term? ln of x times the first derivative? 12. Well, 12x times 1 over x, the x's cancel, so you're just 12 plus 12 ln of x is what it works out to be. 12 plus 12 ln of x. Okay? Product rule. So you'll have e to the x's, you might have some trig functions in there, and so on. Okay? Quotient rule. If we're told to take the first derivative of 2x minus 3 over 5x plus 7. Well, since that's in a quotient, we take the denominator, 5x plus 7, times the first derivative of the numerator, 2, minus 2x minus 3 times first derivative, which is 5, over the denominator squared, 5x plus 7 squared. So if we distribute on top, we get 10x plus 14 minus 10x minus 15 over 5x plus 7, 20 squared. So we have to distribute our negative. This is everybody's biggest downfall. They would just write minus 10x minus 15. No, it's not. It's negative 10x plus 15. So it's actually 29 over 5x plus 7, 20 squared. That is the first derivative of that. Okay? All right. The first derivative of the tangent of x is the same as the first derivative of what over what? Sine of x over cosine of x. If I had sine of x over cosine of x and I didn't have tangent of x, I would have to use the what rule? Quotient rule. Quotient rule is the cosine of x times, what's the first derivative of the sine of x? Cosine of x, minus the numerator, the sine of x, times what's the first derivative of the cosine of x? Negative sine of x, all over cosine squared of x, because cosine of x squared is cosine squared of x, if you remember your trig. Well, what's cosine times cosine? Cosine squared of x minus a negative sine squared of x. Minus a negative is plus a positive. What's cosine squared plus sine squared? Thinking back to our trig identities. 1, that's a Pythagorean identity, which is 1 over cosine squared of x, which is, what's 1 over cosine squared? It's secant squared of x. That's why the first derivative of tangent is secant squared of x. And we can prove every one of those trig ones. Okay? Let's prove the first derivative of secant once. Okay, I got to somehow prove the first derivative of secant. So how would I do that? Secant is 1 over cosine. So if I'm going to do the product or the quotient rule, it would be cosine of x, the denominator, times the first derivative of the numerator. What's the first derivative of 1? 0, minus the numerator 1 times the first derivative of the denominator, which is negative sine of x, all over the cosine squared of x. Well, cosine times 0 is 0. So it's 0 minus a negative sine of x, which is plus a positive. So it's really sine of x over cosine squared of x, which is sine of x over cosine of x times 1 over cosine of x, which is 1 over cosine of x is secant of x. Sine of x over cosine of x is tangent of x. Okay? So that's why the first derivative of secant is secant times tangent. And I could prove this for all 4 of them, but we're not going to go into that. Okay? So, are we good for today? Okay, so you're going to have lots of stuff to do today. Lots and lots. So